Okay, here's another pair of simple patterns. Again, we've got some order objects and a few sample orders. And in our first method, we're counting the number of orders that have been refunded by looping through and incrementing a counter variable for each order that has the status of refunded. And in the second method, we're calculating the total value of all the orders in the collection by looping through again and adding the order amount to a running total variable. And when we run, we can see that we've got one refunded order and we've got an order total of £107. Now, can these methods be simplified with LINQ? Absolutely. Do you know which LINQ methods we could use here? Well, to count orders, we simply can use the count extension method, passing in a lambda expression to select the orders that we want to count, which in this case are the refunded orders. By the way, you can also call count without passing in a lambda, and that will simply count how many elements are there in the entire sequence. And to add up the total value of all the orders in our sequence, then we can use the sum extension method. And we'll pass in a lambda expression to select the value of each order that we want to sum. So let's quickly run these and check that we get the same results as before. And yes, that looks good. So as you can see, once again, both of these LINQ extension methods give us a really nice simplification of our code, turning about 8 lines in the original implementation into a single line. And again, it expresses what we're trying to achieve very clearly. So this is another really great pattern to look out for when you've got for each loops like this, and take advantage of these LINQ extension methods of count and sum. Let's just look at one final pattern before we go on to look at the solution to our LINQ challenge.